All right, welcome to the formative assessment. What is this? 4.4, I think, inclined planes, right? Um, so you get this stuff, right? You get the mass of it, the incline, right? And then there's all these coefficients. And what you got to do is you got to calculate these guys before you can really even begin the problem, right? I don't really need to calculate the reaction force separately, but the static force and the dynamic force of friction and the parallel force. These are the things that you're going to use to solve the problem, right? So the parallel force is going to be, remember gravity is straight down, right? So the component parallel to the plane is actually, there's a right angle, right? This is the parallel component right there, okay? Since it's opposite the side here, the hypotenuse is mg, and since it's the side opposite this angle, which is the same as this angle, it is mg sine of that angle, right? So force parallel is mg sine of that angle. And that's just the part of gravity that's parallel to the plane. In this case, it's 5.2 times 9.81 times sine of 30 degrees. All right, let's do that. 5.2 times 9.81. Oh, I got to turn my calculator on to do that kind of stuff. 5.2 times 9.81 times sine of 30. 25.506. Right, and that's a force that'll always act down the plane. It's always going to act this way, right? Every single problem we do, that guy will act down the plane. We will always put it as a force in F equals ma, and we'll make it negative. Okay, and then the force of friction, the static maximum force of friction. Force of frictions in general are a coefficient times the reaction force. In this case, the reaction force is mg cos theta. So if you look at that little triangle, I don't draw this triangle every time because I've done so many of these problems, right? But this part of the weight that is actually perpendicular to the plane is the adjacent side of the angle. So it's hypotenuse times the cosine of that angle. Okay, so for this case, since we want the static maximum one, I guess I'll use the static coefficient of friction. So 0.65 times 5.2 times 9.81 times the cosine of 30. And this definitely won't come out even. Okay, so let's see, 0.65 times 5.2 times 9.81 times cosine of 30. That is 28.715. Newtons, and that's the maximum that the static friction can be. In general, it's whatever it needs to be to keep it from moving, okay? So if it's resting on the plane and 25.506 newtons is down the plane, right, that static force would just keep it from moving. So it wouldn't be any more or any less than 25.506. It would be exactly equal to it, right? So it's anything from 0 to that, okay, that would keep it from moving. So in this case, it's actually, if it's sitting still on the plane, it would actually be that, right? And then the dynamic force of friction is going to be mu times r, which is going to be mu times mg cos theta, right? And then that's going to be 0.120 times 5.2 times 9.81 times the cosine of 30. All of this stuff, it seems like we should be done with the problem yet. We haven't even begun the problem yet, right? So 0.12 times 5.2 times 9.81 times the cosine of 30. Ooh, what did I just do? Times the cosine of 30. I think I hit enter accidentally, prematurely. 5.301. Okay, so this guy here, this is the dynamic friction. Dynamic means to move, okay, in this case. And so this thing is going to always be opposite the slide. So if I'm sliding up the plane, this will be down the plane. If I'm sliding down the plane, this will be up the plane. It always opposes the direction you're sliding, just like the regular friction problems, okay? This guy's a player in all of them. This guy's a player in all of them. This one's only relevant if it's sitting still, okay? Now, these are not in the data packet. The sine and the cosine are not in the data packet. So here's how you remember it, okay? If it's level, then theta equals 0, and force parallel also equals 0. So now the question is, I mean, it's either mg sine theta or mg cos is the force parallel, right? If you can't remember that, just remember that sine of 0 is 0. That's supposed to be a 0. The sine of 0 is 0, okay? And if you can't remember that, your calculator can remember that. And that's how lame I was when I was a student, is I couldn't remember. So let's see, cos 0, nope, not that one. Sine of 0, yep, sine of 0, 0. And I'd use that one for the parallel force, okay? Anyway, just bust these out, you know, I don't know, do that a bunch of times. And really, you just do this, and you don't even talk about it as much as I did, and you've got that done. And then what I'm going to do is solve all the rest of these things, okay?